Welcome to Let's Get to the Marks, going through an A-level chemistry question on amines. Let's get on with a walkthrough. This question's about amines. 9.1. An incomplete equation for step 1 in the reaction between bromoethane and an amine is shown. Complete the equation. In step 2 of this reaction, the product of step 1 forms a secondary amine. Name the secondary amine formed. So these two little bits are worth 2 marks. Why don't you pause the video, grab a pen, grab a paper, try and have a go on some scrap paper, and then unpause and watch the walkthrough. Okay, look, check this out. There's a bromine atom on the bromoethane, and obviously the bromine atom has come off. It's become a bromide ion, and we can see here that this bit I've circled in green has replaced the bromine atom. So all I need to do is redraw that with that bit there. All I need to do is redraw that and show the other reagent, which is going to be this, methylamine. So we're just going to draw methylamine out here. So just like that, easy peasy. You could count up the H's, count up the C's, N's, and BR, and make sure your conservation of mass, everything's the same. So that one was quite easy. Step 2 of this reaction, the product of step 1 forms a secondary amine. Name the secondary amine. So what happens? Let's look. This at the moment, if we look at the nitrogen atom on our product here, it's got a positive sign on it. It's not an amine, it's like an ammonium right there. So what we're going to do is this hydrogen is going to donate its pair of electrons from its bond to the nitrogen, and that hydrogen ion, that H plus ion, is going to go on and join the bromide ion and become HBr, sorry. What I need to do is just redraw that -1 hydrogen and name it. Now I can't be bothered to redraw it, so I'm just going to scribble it out. Now, how do we name this? Well, this is actually an N substituted amine. And that is when you find a nitrogen atom in the middle of the carbon chain of an organic molecule, then you know it's an N substituted amine. Now we've got the two side groups. We've got the methyl group and we've got the ethyl group either side of the N. Now think about it. It was actually methylamine, but now we've kind of got ethylamine because there's two carbons with a nitrogen on the end, and then we've got a methyl group. So how do we name that? Well, we can call it N-methyl ethylamine. There's a whole bunch of different names for this. But I would prefer the N-methyl group on ethylamine. And just to show you that, this would be what I would call ethylamine because the longest chain. So I like to call that ethylamine. And then just explain that there's a methyl group attached to the N. So the CH3 at the N there near the bromide ion is attached to the N. So I'm just kind of saying N-methyl ethylamine. And that is the name that I'm giving it. But there's plenty of other options. You can check them out for the other IUPAC options here in the mark scheme. Check out the link. 9.2. Right, we have, that looks like 2-bromobutane, and it reacts with ammonia. Draw the skeletal formula of the major organic product formed when an excess of ammonia is used or an excess of 2-bromobutane is used. Product with excess ammonia, product with excess 2-bromobutane. Grab your pen, grab your paper, pause the video, have a go, and then we shall go through the explanation. Okay, here comes the answer. Essentially, I'm drawing the skeletal formula. What I want to do is, with the ammonia, we're going to get the NH2 group swapping for the Br. So the Br is going to be substituted for an NH2. I just need to make sure with skeletal I've got the right amount of carbons. That's butane, isn't it? 4 carbons. Now remove those Cs. That's the skeletal. And at each point of the skeletal is a carbon. And what I want to do here is just attach the NH2. So that is my product with excess ammonia. You're just going to get all of those bromines on the bromobutane is going to be swapped for an amine group. So you're going to have, butan 2-amine or whatever it's called. Right, what have we got going on here? We have product with excess a bromobutane. So what's going to happen, because there's a lone pair on that amine group that's attached, the NH2, it's able to join to another one of these bromobutanes, and the hydrogen is substituted. So you can work out how many more can join. So look, it would start off like that. There's our NH2 group attached. Now another bromobutane would attack here. And so we're going to draw another one on, and that will delete one of the hydrogens. One of the hydrogens has been swapped the bond area has been exchanged. Now, look, the next bromobutane will come and attach because the nitrogen still has a lone pair, and that hydrogen goes. And guess what? We've now got 3 bonds around the nitrogen. That still means there's a lone pair left over. And remember, nitrogen can form 4 bonds, but it does get a positive charge, becomes a nitronium ion. And here, and just like in ammonia with NH4 plus, you're going to end up with 4 side groups, 4 of those organic molecules coming off the side. So this is a nitronium ion. And guess what? If you can think of the name for that, I'm going to try and name it really poorly, but I will attempt to name this. Okay, so what would this be called? You can put me up in the chat because I'm not sure this is correct, but yeah, I think this would be 2,2,2 tetrabutyl ammonium bromide. Okay, because you've got these butylamines, whatever they are, attached on the sides. Anyway, hit me up in the comments. Let me know if that's wrong. Let me know what the correct name for this quaternary ammonium ion is. Okay, let's go. Right, 9.3. Figure 3 shows a 2-step synthesis to make amine G. We got step 1 seems to have made a nitrile and released a bromide ion. Okay, so we're probably coming from a haloalkane, right? And then in step 2, we've got our nitrile being attacked by hydrogen and forming amine G. So complete figure 3 by drawing the mechanism for step 1 and the displayed formula of amine G. It's worth 3 marks. You know what to do. Grab your pen, grab your paper, have a go at this one. Pause the video so you don't watch the explanation first, and then unpause and I'll go through more or less how to do it. Let's hope. All right, I'm going to go through the answer. So we've got a bromide ion there. That gives me a clue that it looks like the bromide ion has come off. So that gives me a clue that something's been substituted for the bromine. That's going to be that CN, that nitrile ion is going to have been substituted. So I'm going to draw out my little thing here. No, did he? So I've got CH3 that means, and a CH, that means that these 2 methyl groups are coming off a carbon with another hydrogen coming off. So where am I going to put that hydrogen? Who knows? I could put it here on the side or I could put it down below. It's kind of my choice. And then the bromine would have originally been connected to that as well. Oops, let's put the bromine here. I don't know if I should put the bromide ion there or down below. Doesn't really matter, I guess. It's kind of 2-bromopropane, isn't it? The bromine is attached to the second carbon in the chain. So I could have just done a straight chain of carbons, but I think I'll do it like this to give room to show where the nitrile attacks. So this is going to be nucleophilic substitution because it's got a lone pair with a negative charge. It's attracted to that delta positive carbon. Now in AQA, you don't need to use the delta symbol, but I like to still do that just to show where it's going to attack. And then, of course, bromine can't have, bromine's going to have to break off. That bromide ion is going to be released because carbon can only have 4 bonds. It can't have 5. And there we go. That is going to be the steps. And that's probably going to get you 2 marks for the mechanism right there. Now let's look at amine G and what's going on here. So the clue here is that the nitrile is being attacked by the 2 hydrogen molecules. So I need to add 4 hydrogens on. You see I've written them down there in pink. Basically, I need to add 4 hydrogens to this to make amine G. We can see there's no other product, so it's an addition reaction. So I'm drawing this out. This is what it looks like at the start. This is what this molecule up here, the end of the product of step 1 would be. And now we're adding 4 hydrogens to this. So where am I going to, I'm going to need to get rid of that triple bond, right? And then you just fill out the hydrogens. So 2 hydrogens coming off the C, that's 4 bonds around the nitrogen. And then the nitrogen likes to have 3 bonds there. What did I say? 4 bonds around the hydrogen. Well, anyway, I'm waffling here. Carbon atoms only like to have 4 bonds. They're in group 4. So 2 hydrogens attached there and 2 to the nitrogen, which generally likes to have 3 bonds, although it can form that nitronium ion when it gets the positive charge. And I don't know what I would name this. What would you name this? 2-methylpropylamine? Or is it 2-methylpropanamine? What would you call this? Why don't you put in the comments what you'd call this? It's not one of the marks, but there we go. All right, let's move down to 9.4. Figure 4. Figure 4 shows 2 amines, P and Q. Explain why P is a stronger base than Q. So why is it that amine P is a better base? What do bases do? Remember the definition of a base? So why is it a better base? Okay, press pause on the video and have a go at this one. Now I'm going to go through the explanation. Check out these groups. What do we call these? These are alkyl groups or R groups. They're actually methyl groups in this situation. And you can see Q only has one methyl group, whereas amine P has two methyl groups. So what we want to say, it has more methyl groups or alkyl groups. These alkyl groups, you can see I've drawn a little arrow going towards the nitrogen. They have a positive inductive effect where they release electrons. They kind of donate their electron cloud towards the nitrogen. This increases the electron cloud around the lone pair on the nitrogen and makes that lone pair more available, it's able to accept a proton. So the lone pair on the nitrogen is more available and the nitrogen is more able to accept a proton. So if you look at the electron cloud on the lone pair on the nitrogen with the two alkyl groups, it's going to be bigger, and it's going to be able to accept that hydrogen. That's it. Sharing's caring. Hit the like, punch up the bell, subscribe. Let's get to the marks. All right, I'll catch you lot in the next
You're
vid.
still here? It's over.